Hello students, today we will start K-map to minimize the logic function or Boolean function using K-map method. In previous class we have discussed in 4 variable K-map. In 4 variable K-map the min terms are given, min term or max terms, how to find out the minimal sum of product and minimal product of sum. In this example, if you will do more and more number of problems, your concept will be clear. So in 4 variable K-map, so here you have to find out the minimization of the logic function using K-map. We have to find out the minimal SOP or minimal sum of product. In 4 variable K-map, first of all, we have to construct the K-map, 4 variable K-map. In 4 variable K-map, there is your 2 to the power 4, there is your 16 squares or 16 cells. First of all, construct the 4 variable K-map, then put the min terms are given. These are the min terms. The min terms are represented by binary 1. So you should put in respective cells or respective squares the binary 1. Then combination of 1s will give what? The minimal product terms. So here in 4 variable here given 4 variable are A, B, C, D. This is your A, B and this is your C, D. This is your C bar, D bar. This is your C bar, D, C, D and C, D bar. Here this is your A bar, B bar. This is your A bar, B and this is your A, B and this is your what? A, B bar. So you may write that is your what? That is your the respective positions. This is your 0, your 1, this is your 2 and this is your 3, your 4, 5, 6 and 7 and this is your 8, 9 and this is your 10 and this is your 11, your 12 and this is your 13, this is your 14 and this is your 15. These squares represent the decimal 0, here decimal 1. If you combine A bar, B bar, C bar, D and the value will be 1. This is your 2 means A bar, B bar, C, D bar. This square represents A bar, B bar, C, D bar. The decimal value that is 2. So in this way, first of all consider the 4 variable K-map, 16 squares, and in respect in each square you have to put the min terms. Here the min terms position 0, there will be 1 here. The min terms are represented by binary 1. Similarly 1, where is 1? Here, there is 1. 3, where is 3? Then 5, that is your 5. And this is 7, your 7. Then 8, where is your 8? This is your 8. And then 9. Then 11. And then 13. And this is your 15. Okay. So there will be in each place of the square you have to put the binary 1. Since the min terms given, the combination of min terms, we form a group. Group may be pair, group may be your quad and group may be your octet. So if the octet means 8 1s to form a group and 8 1s form a group out of 4 variable and 3 variable will be removed, only you found 1 variable. Similarly in case of quad means combination of 4 1s, if you combine 4 1s and 2 variable will be reduced and you will get 2 variable. Similarly pair means 1 variable will be reduced. So accordingly, and the remaining squares you will put what? That is your 0. That is your 0. The remaining square you will put that is your 0. Then what will do? Then we will go for that is your what? That is your grouping. If there is a octet means combination of 8 1s, you form an octet. To form a large group, if large group is possible, you should avoid the if octet is possible, you have to avoid quad and pair. If you look here, this 1 1 1 1 and this 8 1s, so that's why you can form a group here. We can say one octet. So this is a one group. We can say this is your group 1 or loop 1. This is your group 1. And care should be taken, all 1 should be covered up. Means there is another 2 1 is left. And these 2 1 I can form a group. You can form a group, but this 1, 2 1, if like this. Since these 2 1 already it has already been engaged in group 1, so no problem. So this one can be combined with these two one, can be combined with these two ones to form a quad. So that is your group 1 and this is your what? That is your group 2. So group 1, what will found from group 1? In group 1, what will found? Here in this one, in column wise, all are different means cancel out. But in this case, this is your C bar D and this is your CD. The common is what? C bar D and CD. The common is only what? D. So this group gives you the value what? That is your D. That means if 81 you will combine, the result will be only D. So in as usual method, using if you apply the Boolean equation, Boolean laws of Boolean algebra. So this plus this plus this plus this like this, you will apply a plus a bar 1, a into a bar 0 like this. You will find D, but after doing so many steps, you will find D. But using K-map, you will form a group, then you will find only D. So in this group 1, this group gives you the value is D. Then another group, here this 2 1 and here this 2 1. And here in this one and this one, where is your common? These are A bar B bar and these are A B bar. The common is what? That only B bar. And this wise you will see found only B bar, and this one and common is what? That is your C bar. That means this 4 1s gives you, this is your what? The common is B bar and here the common is C bar. That is your B bar, C bar. In the group 2, the result is your what? B bar, C bar. Okay. So minimization, this logic expression using K-map, if you apply K-map, the value is your what? One group gives you D, another group gives you B bar, C bar. Therefore, the minimal sum of product, the minimal SOP, minimal sum of product equal to, that is your D plus B bar, C bar, D plus B bar, C bar. So a K-map method is very quickly you can find out what is your value of minimal SOP. So next example, if you go through the next example, this one, simplify this logic expression using K-map. How to simplify this logic expression using K-map? First, since this it is your 4 variable, as usual process, first construct the 4 variable K-map, that is your 16 squares. So then in 4 variable K-map, so this is your AB and this is your CD, and like this you just write down this one, and here A bar B bar and A bar B, this is your AB and this is your AB bar. Already you know the position of squares, and this value is your what? 0, this is your 1, this is your 2 and this is your 3, this is your 4, 5, 6, 7, 8, 9, 10 and this is your 11, 12, 13 and this is your 14 and this is your 15. Then you will put what are the values given, mean term is given. Here this is your 0, in 0 there is a mean term 1, there is 1, there is a mean terms, 2 there is a mean terms, 5 there is a mean terms, 7 also mean terms, then 8, here there is your 8 and this is your 9, this is your 10 and this is your 13 and another one is your what? This is your 15. Okay. So how many number of mean terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you just remember this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to avoid, if any mean terms you left, your all the calculation will be wrong. So you have to look carefully whether a mean term is perfectly placed in your respective squares or not. So there are 10 mean terms. So in 10 mean terms, the mean terms can be represented binary. So 10 mean terms should be placed in a respective cells or respective squares. In the remaining squares, you will put, that is your what? That is your 0. Remaining squares you will put 0. Then what we will do? Then we will form a group. Already I told you, you should form a large group and avoid a reductant group. Reductant group means unnecessary group. So here Then what we'll do first? This is nothing but a 1. You can form a group here. This is a 1 quad will form. Okay. Look at this. These 4 corners form a group. These 4 corners form one group. All the groups should be, all ones should be covered up. This is on one what? If you roll like this, the adjacent one is this, adjacent one of this, adjacent one of this, like this. These 4 corners form a group. So we can say, let this is your what? This is your group 1. This is your group 1. So 4 corners form a group. This is your group 1. This is your group 2. Then what? This 2 1. This 2 1, you can form a group also here. This is your group 3. Okay. Then from group 1, what we will find? Look at this here. These 4 corners form a group. In this one, what is common here? C bar, D bar, this is C D bar is common. And from here, this 2 1 and A bar, B bar, this is A B bar, A bar, B bar, A B bar, that is a B bar is common. If you look from this, that is a B bar is common. If you look this, the D bar is common. So group 1 gives you what? That is your B bar, D bar. So group 1 is nothing but what? That is your B bar, D bar. Similarly, in group 2, there is a quad also here. There is your C bar D. All are cancel out. So there is nothing is common here. Only C bar D is common. In group 2 gives you what? That is your C bar D. Similarly, that is your group 3. In group 3, this is also a quad. This is also a quad. 4 1s form a group. If you look this here, the common is what? A bar B and A B. The common is your B. Here the common is B. And if you look this one, this side, the C bar D and this your CD, the common is what? The common is D. That means these 4 1s form a quad and gives you what? This is your B and this is your what? D. This group 3 result, that is your BD. Okay. So 3 groups gives you result. 1 group is your B bar, D bar. 4 corners form a group. Here that is your D bar. Here that is your B bar. That's why group 1 gives you B bar, D bar. In group 2, and that is your only C bar D. All are cancelled out. Only C bar D. And in group 3, these 4 1s form a group, quad, form a group. That is your what? In this side, that is your D, and this is nothing but is your B. That is your BD. So therefore, the minimal sum of product, minimal SOP, minimal sum of product equal to your B bar, D bar. That is your C bar D, and this is your what? That is your BD. And this is, in this way, using KMF, you can minimize a logic function using KMF in a 4 variable KMF. So and then we will go for the next example. Here also, your f of ABCD equal to 3, 4, 5, 7, 9, 13, 14 and 15. How to simplify the logic expression using KMF? Since it is a 4 variable, similarly you construct the 4 variable KMF. 4 variable is nothing but what? 16 squares. In 16 squares, put the mean terms in respective squares and grouping the mean terms, then find out the minimal product terms. Then if you add all the product terms, you will give the minimal sum of product. First of all, consider the 4 variable KMF and put the mean terms in respective squares here. Okay. So first of all, you know the particularly this square corresponds to what? The decimal 0. This is your 1, and this is your 2 and 3. This is 4, 5, 6 and 7, 8. This is your 9, and this is your 10 and 11. This is your 12, 13. This is your 14 and 15. You just know the position of each square. The position of each square means the decimal value. The position of this square corresponds to decimal value 0, and position of this square corresponds to the decimal value 1, like this. So the question given 3, 4, 5, 7, 9, 13, 14, 15 means mean terms have been given in these positions. And in position 3, there is a mean term. So mean term is represented by binary 1, 3, this is your 4, 5, and this is also 7. 9 also there is a mean terms, 13 is also there is a mean terms, and 14 is also there is a mean terms, and 15 is also a mean terms. Okay. So then how many number of mean terms given? 1, 2, 3, 4, 5, 6, 7, 8. So there has been 8 number of mean terms. 1, 2, 3, 4, 5, 6, 7, 8. So you should look, there is no mean terms would not have been missed, because if you missed one mean terms, your entire calculation will be wrong. So in this case, the 9 mean terms you have perfectly placed in a squares, and remaining squares you will put what? That is your 0. That is your what? That will be 0. So after placing all the mean terms in respective squares, then you will go for a group. So how to form a group here? Remember here all the ones should be covered up. Okay. So this 4 1s, this one I can form a group here like this. Here also like this. And here it is also like this. It is like this. Okay. You can ask, why will not I will take these 4 1s? Why I will not consider this 4 1 is form a what? Is a quad. This will be wrong. If I will consider this 4 1, that it will be wrong, because it is a reductant group. Since there is a 4 pair, this one to form a pair with this one, it is a must. There is no adjacent one of these mean terms. So this pair will be must. Similarly, this one, there will be no adjacent one mean terms of these mean terms, because it can combine with this. This is compulsory group. And this one, it can be compulsory with this group. And this one also, this one can be combined with this one. So that's why this 4 1 already has been engaged in other pairs. So if I will form this group, it is an unnecessary group or reductant group, and it should be avoided. So that's why this 4 pair is possible. In this example, this is 4 pair is possible. So if we will group like this, your calculation will be wrong. So that's why the 4 pair here, that will be what? This is group 1, this is your group 2, and this is your group 3, and this is your what? Now group 4. So group 1, what we will get? Group 1, in group 1, this is your what? This is CD. That's why A bar, B bar, this is A bar, B, this will be cancelled out, only CD. Group 1, this one, if you will consider this one, in this side, your A bar is common here, and this is your CD. In group 1 gives you A bar, CD. In pairing, one variable will be reduced. In 4 variable, out of 4 variable, 1 variable will be reduced, and we will get only 3 variable. Either maybe it will maybe true form or complementary form. So that's why it will be A bar, CD. Similarly, in group 2, here, that is AB, here AB, and here common is what? That is your C. That is your ABC. Group 2. In group 3, what? The common is what here? That is your only A. Here the common is C bar D. A, C bar D. This is the group 3. Then group 4. In group 4, that is your what? This is your A bar B, and this is your what? This is your C bar D bar, this is your C bar D. C bar is common, and A bar B, C bar. A bar B, C bar. In group 4, you will get this one. So therefore, we can write minimal sum of product, minimal SOP, that will be for what? A bar CD plus ABC plus AC bar D plus A bar B C bar. So in this way, we will minimize the logic expression using K-map. So thank you. We will meet again on the next class. Again, we will do more and more number of problems. So how to minimize the logic function using K-map.